And welcome everybody to the Daily Space Weather Show. A little bit about the channel. The origin of these videos is based on what I wanted to look at. So I realized in the mid-1990s that I wanted to be a cosmologist. However, it wasn't really offered as a major, and I realized that there was a huge hole in cosmology when it came to heliophysics. I figured, I don't think we understand the sun very well, at least not widely speaking, and so I realized that a deep dive needs to be made. Then in the late 20-teens, I realized that there's a hole in YouTube as well for this sort of content, so here we are. Don't curse the darkness, folks. Light a candle. Anyway, this is the past 24 hours from SDO. We're looking at our composite wavelength that it's optimized for viewing filaments. You may see a lot of plasma filaments at the moment. 304 angstroms plus 193 angstroms from the SDO is a great pair of wavelengths to use to view solar filaments. And let's take a little closer look, as we're known to do. So here's the northern hemisphere, and you can see a bit of a polar vortex going on up there. Those crown prominences can be expected to become more and more common in the coming around 1 year period of time. That is because we're like about a year away from solar maximum. Here's a little closer view of that crown prominence, sort of encircling the polar region. Also a huge filament there to the south of our Earth scale. You can see that looking like it's perhaps getting a little bit unstable. We've also got massive filaments setting on the western limb. It's another case of filaments, folks. And these are known to turn into coronal mass ejections, although sometimes they also collapse. Sometimes they even reorient themselves, anchoring themselves to another portion of the sun as magnetic fields suspend them, defying gravity. Here's the southern hemisphere. And you may see a filament release down there, just up and to the right of the Earth scale to its northwest. What's that? You'd like a closer look at that as well. I think we can probably accommodate you there. There's a closer look at that filament release. So that one does include both a CME, coronal mass ejection, as well as some of that filamentary material splashing back down toward the chromosphere. That's the layer of the sun's atmosphere below the corona and above the photosphere, which you could call the solar surface. We've also got some active regions rising in the eastern limb. And we have some significant solar flare players over there in the east as well. We'll talk about the likelihood of solar flares moving forward momentarily here in the video. First, let's take a look at this action. And there's another great example of a filament splashing back down toward the solar chromosphere. You can also see a brightening there. You'll see like a pinkish color emerge. That is a sudden brightening of the 193 angstroms wavelength. That's the ionized iron featured in this composite view. By the way, these are all 24-hour videos. And there's a zoom out of the eastern portion. Again, a couple new active regions look like they are rising there. And let's briefly look at sunspots. So here is August 23rd, the entire day, and August 24th to date. The most significant solar flare player is certainly this sunspot right here. It has grown as forecast. This sunspot group down here is the second most likely place to see a large flare. Let's check out the colorized magnetogram for the same period of time. And let's take a brief look at planet Earth. Again, this is the information that I figured that I wanted to look at daily, folks, because, well, there was some content on YouTube covering similar subjects, but it isn't any good. It's crap. And so we always tell the truth and then we never slip no lies in, to quote Run DMC. Here are the volcanoes that are currently erupting. Mount Mayan's producing a 9,000-foot ash plume. Check it out. There's Luatolo exploding. Karengatang also producing an 8,000-foot ash plume as it explodes. It's a flight level 080. Luatolo, 7,000-foot ash plume, exploding and effusing. So creating some new real estate there as well as blowing out some ash. Nevado del Ruiz, volcanic ash emissions continue over Colombia. Sangay in Ecuador exploding, flight level 200. It's a 20,000-foot ash plume. Revenador in that same country exploding, flight level 150. It's a 15,000-foot ash plume. Active lava flow there on the northeastern flank, as well as Volcanian-style explosions. Sabancaya in Peru exploding, flight level 210, and we're not sure about Ubinas. Please do not pole vault the caldera. It could be unhealthful. Next, looking at seismicity, and there was one significant quake over the past 24 hours. However, it was at extreme depth. It was located in Argentina. And there is the location of that. It was a 6.2 magnitude quake, quite far inland on the South American continent there. So there is the location of that. That 6.2 was at 1422 Universal Time and at a depth of nearly 570 kilometers estimated depth there. If that would have happened at the surface, that would have been, let's see, that would have been like a mid-7 magnitude quake had that happened at the surface. We'll call out quakes of a 5 magnitude or greater over the past 24 hours, and there weren't too many there. There was a 5.3 at Chile, and that was only 20 minutes ahead of that 6.2 at Argentina. So there you go, 2 quakes in succession, a 5.3 and a 6.2. Keep in mind, any earthquake can be a foreshock. Perhaps this 5.1 in the South Sandwich Islands region was a foreshock. It happened at 1751 Universal Time yesterday afternoon. Mariana Islands region had a 5.4. That was at 4 o'clock Universal Time this morning. And that closes out our list of 5 and greater magnitude quakes. And let's take a look at the closest star once again. There is the SDO imagery for the past 24 hours. The quiet corona, the transition region, the lower corona, ionized iron in 171 angstroms. Again, the most likely place to see large flares is indeed in the east. We've got 2 large magnetically complex sunspot groups over there, as well as some new active regions rising. So we have been seeing an uptick in the X-ray flux here just over the past few hours. We'll get to it. But first, let's talk stats. So, the 10.7 centimeter radio flux stalling here at 147 solar flux units. And we're going to show you comparisons of the solar cycles here in just a moment. There's the 1-year graph of the radio flux represented by that black line. The pink line below it is the 30-day Wolf number. That's a sunspot average over 30 days. And then you've got the red line, which is a sunspot number. The blue line is the AP index, which is just an average of global geomagnetism. So looking at the Space Weather Enthusiast dashboard here, I just want to show you how much stronger of a cycle solar cycle 25 clearly is. So here you can see solar cycle 25 with this steep ramp up, well above expectations. Not looking like a weak solar cycle like solar cycle 24 at all. It's looking more like an average solar cycle, at least. So if you're worried about the sun shutting down, you should stop worrying, because solar cycle 25 is going to vastly exceed solar cycle 24. It might even be a stronger solar cycle than solar cycle 23. It's nowhere near solar cycle 24. And what we're seeing here, this little lull in activity, is nothing like a double peak. The double peak of solar cycle 24 was a lengthy period of time there, like a year, with average sunspot number somewhere below 100. Don't expect to see that at all. That's a pretty rare thing. Solar cycle 25 expected to be much stronger than solar cycle 24. That's the 10.7 centimeter radio flux, by the way. This is the sunspot number, and you can see how proportional those 2 data sets are. Some people worried about the sun shutting down, and that's just not the case. So here's a Space Weather Enthusiast dashboard forecast. We don't see any space weather in the forecast here. No geomagnetic storms, no CME impacts, coronal hole high-speed streams, or anything in the forecast. It is calm conditions here at the moment in the solar system. Let's take a look at Earth's magnetic moment from space here. Here's the past 4 hours of magnetohydrodynamic pressure out to about 12 Earth diameters. Our geospace magnetosphere movie. Magnetohydrodynamic pressure is measured in units called nanopascals, and that is what this model simulates for the past 4 hours. There you have it. Geomagnetically calm conditions indeed. Here's Earth's magnetic moment from the ground. The units here are nanotesla, which is magnetic flux density. This will show you the most likely places to see the aurorae. Also, induction into the power grid. Those are the Earth's telluric currents and their likely locations. If you're worried about a pole flip, well, where are the quadrupoles, octopoles, hexapoles, etc.? It is extremely unlikely for Earth's poles to flip. The geologic record tends to agree with what I've just stated, and this data also supports that theory. That's the past 4 hours of Earth's magnetic moment from the ground. And let's take a look at some more stats here. Planetary K-index currently at 1.33. KP 1.33 is a very geomagnetically calm scenario. The planetary K-index is an average of global geomagnetism. And let's take a look at the real-time solar wind here. So we're seeing quite a diffuse solar wind at about 2 protons per cubic centimeter here at the moment, as measured by the ACE and Discover. 2 protons per cubic centimeter is a solar wind density. Solar wind velocity here just under 400 kilometers per second. That's pretty unremarkable. GOES magnetometers here showing some smooth curves over the past 3 days. It is a chill geomagnetic environment. And let's move on to look at the top view ecliptic plane field plot. So the sun is always putting out plasma. That plasma is oriented to one magnetic pole or the other. Earth is currently in a south pole current sheet. However, by tomorrow's video, that's likely to end. So if you look at the last image there is a bit of a magnetic tug-of-war happening, especially in the northeastern limb, which we'll show you here in a moment. And that does affect the polarity of the solar plasma. Now, keep in mind, this is only showing one thin slice of that plasma's polarity because it's only showing the ecliptic plane. And so keep in mind, that is a three-dimensional, the Parker solar spiral, which is the plasma that comes out of the sun, that is a three-dimensional lumpy plasma formation. So this is only showing you the polarity around the ecliptic plane, which is the path Earth takes around the sun. Anyway, here's the latest image. There is a North Pole current sheet headed this way, and it is possible that it will be here as early as later today. And here's our line of sight field plot. So you're going to see some motion happening up in this area. That is because there's some indecision happening with the polarity of coronal holes up there, which we'll show you next. The sun's B field here is depicted in blue. That's the field that goes through the magnet, this magnet being the closest star. So here's our line of sight coronal hole plot. And you'll see some variation happening up here. So that is because it's trying to decide whether or not those coronal holes are north or south pole. So let's briefly look at SDO 211 angstroms. And there are coronal holes from the Solar Dynamics Observatory's perspective. It's another 24-hour video, 211 angstroms, another of the many species of ionized iron emitting extreme ultraviolet light. It's very, very hot gas in the sun's atmosphere. Let's go back to our line of sight coronal hole plot. Look at the last image. At the moment, we've got south pole coronal holes in the northwestern limb, and the rest of those are north pole coronal holes at the moment. Moving on to sunspots. No new groups, but we did see a little bit of growth of sunspot 3413 in the past 24 hours as forecast. The most likely places to see large solar flares are 3413 and 3415. There is also a huge, very dense and very concentrated plasma filament right in here, right in between 3413 and 3415. We will show you that here momentarily as well. But first, here's another 24-hour video from SDO. Zoomed in on the equator there, that's 1600 plus 1700 angstroms. So 1600 angstroms is carbon-4, ionized carbon, as well as continuum. 1700 angstroms is a different portion of the continuum, not showing a specific chemical spectra, but part of that is ionized carbon. And once again, the most likely places to see solar flares are those two large sunspots on either side of the Earth scale. Let's switch to the SDO continuum alone. So I don't know, it looks to me like 3414 has a second sunspot to its northeast. I suspect that group is going to get its own name. So we're talking about this group right up here. That is a separate sunspot. So, but it really matters not as far as the overall situation. Naming sunspots is a fairly arbitrary process. And keep in mind, if a sunspot does go all the way around the sun and rise back up across the eastern limb again, it does get a new name. So again, it's pretty arbitrary. They're just numbered in succession. And let's take a look at energetic particles and solar flares. No solar energetic particle events at all. It's been flatlined here for an extended period of time. Don't expect that to continue. Again, we're expecting like 2 more years of quite high solar activity. In fact, 1 year plus of activity higher than what we're currently seeing. So, but no solar energetic particles here at the moment. And again, like I said, there is an uptick happening in the X-ray flux just in the past few hours there. So the X-ray flux looks like it may be coming back up to a C range. We're also seeing some plasma instability in especially the northeastern portion of the closest star. We will show you that here in a moment. First, the last 24 hours in SDO 131 plus 94 angstroms. So these are the best wavelengths to show solar flare activity. It's still part of the extreme ultraviolet wavelengths. And these are both, once again, the extreme ultraviolet emissions of very, very hot ionized iron. In other words, that is iron star. And I am Iron Smash. Thanks for tuning into the Smash News Network, least busted name in news, by the way. And let's take a moment to look up. If you are up before dawn, you might see Venus in your morning sky. The third brightest object. That's what's going on overhead Lehigh Valley. The sun just peeking over the horizon here. Also Deneb, the brightest intrinsic object visible from our solar system, up there in the tail of the Swan, and Jupiter up there, just past the apex of its path across the ecliptic. Here's your solar system forecast. First, the location of heavenly bodies today, and we'll advance this 1 week as we approach the August blue moon, the second full moon in the month of August. That's where things will be in a week. And next, let's classify a galaxy. If you've never seen the Galaxy Zoo project, it's part of Zooniverse.org, the world's largest citizen science project. We need people to classify galaxies because AI is not that I. It's definitely A, but the I is lacking in a lot of ways. And there's definitely a lot of valid criticisms to go along with AI. Is it asinine and idiotic, or is it artificial intelligence? You be the judge. Let us know in the comments. So, this galaxy here, it's certainly got features. It looks like it is a spiral galaxy. So it's definitely not an edge-on disk. And is there a bar? I don't think there's a bar in this one. There's a bulge, but no bar, and we've got a spiral arm pattern for sure. I'm going to say 3 spiral arms, and this is what we would call a tight spiral arm pattern. I'm going to say there are 3 spiral arms there. There is a bulge. We'll say large. And are there obvious bright clumps? I would say there are some bright clumps there. I don't think there is any kind of a disturbance happening in this one. I don't see any significant irregularities. It's fairly symmetrical. And then as far as special features, rare features, let's see. No ring, no lens or arc. There is a little bit of irregularity there, as there are some differently oriented spiral arms. The two in the top here are a little bit tighter than this one down here, also shorter. I think there is a dust lane there. Not sure about any overlap. There are central diffraction spikes. And there you go. Galaxy classified there at Zooniverse.org's Galaxy Zoo project. Today's astronomy picture of the day is Perseids, as photographed by Ali Hosseini Najada. Also featuring the summer triangle there, which consists of Altair, Vega, and Deneb. Again, the tail of the swan showing up in the video. apod.nasa.gov if you want to check out that astronomy picture of the day yourself. And now, coronal mass ejections. So these are yesterday's frames. That's 150 frames from yesterday. And there were some CMEs indeed going on. They do not appear to have earthly directed components, in my opinion, based on the available information. I don't suspect those are earthly directed. Here are today's frames, an additional 40 frames from today. And we'll look at some more CME activity here. We'll add the Soho Lasco C3. That last imagery was C2, and some computer interpolation of it. Difference imagery. And we're expecting an uptick in coronal mass ejection. Let's take a look at stereo A. We like to show this diagram because stereo A is practically in line with the Earth here. So it's not very helpful at providing trajectory, but sometimes it provides data not visible, not uploaded, or for whatever reason not available from Soho Lasco C2 and C3. So let's take a look at stereo A next. And if it looks weird, it's because stereo A's high gain antenna needs to be oriented toward the Earth in order to continue sending its signal. And that causes it to be oriented in a suboptimal fashion with respect to its coronagraph. So that's why it might look a little weird. We show the data just to show you that we've showed the data. We're not hiding anything. And neither is NASA. So here's Soho Lasco C2 and C3 once again. Keep in mind they're not synced. They do include time and date stamps. We've got some custom coronagraph imagery as well. Here is a 24-hour video with Lasco C2 and SDO 193 angstroms. Again, these images are suggesting that these CMEs are not earthly directed. I did see at least one YouTube channel claiming that there is an Earth-directed coronal mass ejection there, and I don't know what they're talking about. I'm not seeing it. But then again, lots of YouTube channels that quote, cover space weather, end quote, talk a lot of nonsense. It's part of the reason our channel exists. Anyway, before we go to filaments, we'll also show the 193 angstroms wavelength all by itself, another species of ionized iron. As the sun is like, I am Iron Star. Anyway, that's what's going on. And again, don't expect the lull in activity to continue here. We're already seeing an uptick, an increase in the likelihood of coronal mass ejections, an increase in the likelihood of solar flares. And let's check out filaments here. And there's definitely a couple filaments that could get named. So here is Lermonth, Australia's ground-based hydrogen alpha imagery. You can see one of those filaments that we showed earlier blasting off from down here in the southwest. Check out the massiveness of this one. It's very dense. It's made the entire transit. That one rose, stayed almost completely stable, and now it's about to set. It's going to become a huge prominence here in the next 24 hours. But the real filament I would be looking at right now is this one, because it's not only very dense, but it's very compact. Usually solar plasma filaments are like, they look like long strings. This one looks like a clump. So that's more of a rare feature. Don't be surprised to see this one eject. It is nestled right between two large sunspots that are certainly capable of producing large solar flares. So that definitely increases the likelihood of coronal mass ejections. There are no less than 24 plasma filaments here on the Earth-facing portion of the solar disk. So expect an uptick. And we like to show the gray as well because it shows prominences. Prominences are the same feature. They're just hanging off of the edge of the solar disk, and you can see a series of prominences, especially around the eastern limb, where we do have some new active regions likely rising. We've got new active regions rising, and to our regular viewers, it's probably not surprising. By the way, if you want to name filaments after living people, go join us over on Twitter. Yeah, Twitter. That's just what it's called. That's a brand. I don't know about this branding, trying to confiscate a letter as your brand. It's just not a brand. Thanks to our new followers over there on Twitter. And if you want to interact with us on social media, that's the best place to do it. If you want to send me an instant message, send it to me on Discord. Yeah, Discord. Here are the past couple of hours. And check it out. This is becoming a CME up here. That is about to eject. So we'll continue streaming that on the Twitch channel throughout the day. More on that here in a moment. That's the past about 2.5 hours from the GOES 16 SUVI. The cool thing about the GOES 16 SUVI is that it has a wider field of view than the SDO. And that really makes it great at showing these prominentary features and the initial portions of coronal mass ejections as they leave the solar corona. The GOES 16 SUVI is fantastic at showing those. It's also good at showing active regions and solar flares. That's why we tend to stream it all day long on the Twitch channel. By the way, that brings us to bonus features. First one being satellite charging hazards. And there aren't any. It's clear sailing. So let's move on through our bonus features here and get to our meteorology segment. Additional bonus features include the GOES electron flux. The GOES 16 and GOES 18, they orbit the Earth in a geosynchronous near equatorial orbit at like 23,000 miles of altitude. They measure the electron flux at the F layer of the ionosphere, which is way down at about 300 kilometers of altitude. The F layer of the ionosphere is what they're measuring the electron flux in. And we're just in an operating range there, a normal range there of relativistic electrons in the greater than or equal to 2 megaelectron volt electron fluence. There is the 1 year graph, and you can see right in the middle of the operating range there, normal levels. And there is the observation represented by the yellow diamond. The green boxes are the Forecast there by NOAA. No arguments with me there. It is calm conditions in space weather at the moment. The F layer of the ionosphere, again, is where that's measured. It's 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with atmospheric temperatures, electromagnetic radiation penetration, and atmospheric molecular density. Here is the F layer's vibrational frequency. We show it daily on the channel. It shows a full day in 2 hours per second. And the ionosphere here is looking fairly normal. Another reason why we don't think there is a pole flip likely, because if there was a pole flip occurring or a significant geomagnetic excursion occurring, we would see constant anomalies in the ionosphere. We don't. Why not? Because these claims that there's a pole flip about to happen are crap. And by the way, the universe is not electric. Everything is not electric. The universe is not electric. Cosmology is not governed by electricity. The electric universe is pseudoscience garbage. It is not science. It is designed to look like science and to trick people who don't understand physics. If everything were electric, why the hell do we need the term electric if everything is electric? Just putting it out there, folks. Just putting it out there. Anyway, there's the latest image. That's 1045 Universal Time ionogram, and there's 1045 Universal Time anomalygram. That's anomaly in megahertz from the 30-day median. We also show the total electron content. More evidence that there's no pole flip occurring. Because if it were, there'd be all kinds of weird additional Van Allen belts forming, and there'd be free electrons in places where you wouldn't expect to see them. There aren't. So here's the total electron content forecast depicting free electrons up to about 12,500 miles of altitude, the inner portion of the outer Van Allen belt. And once again, where are the quadrupoles? Where are the hexapoles? Where are the octopoles? Where are all the weird Van Allen belts that would be forming if there was a significant geomagnetic excursion and a pole flip happening? We don't see them because it's really not a big deal. The movement of the poles, if you're spooked of that, I don't know what to tell you. Take Physics 2, the prerequisite of which is Physics 1. So, I mean, look, grand solar minimum, canceled. Pole flip, canceled. Cosmology nonsense, laughed at. That's your total electron content forecast for the planet. And here it is for North America. That's the anomaly from the 10-day average, and we are seeing some minor high electron count anomalies. These total electron content forecasts are literally a count of free electrons. So there we are seeing some minor high electron count anomalies over especially the western tropical Atlantic. And also the western coast of the U.S. and Mexico. I'll let it play through one more time, and then we'll show the latest images of the closest star in high res. There's the latest image, and there's the latest colorized magnetogram. So this is the most likely location for large solar flares. It is a beta gamma delta class sunspot group, and it has grown a little bit since yesterday. It is the kind of sunspot that typically does produce large flares, like an M class or even an X class event. Again, there is a large plasma filament right down here, like a clump of plasma. This sunspot group down here is also beta gamma class. Just a minute. It is beta gamma class. As far as deltas, it is beta gamma delta class, but just barely. Anyway, here's the full disk image. Again, this area is where you can expect to see large solar flares in the coming 24 hours. And that brings us to our meteorology segment. We're going to start out by doing some wave chasing. Yeah, wave chasing. I'm a wave chaser. What about you? Let us know in the comments. This imagery depicts the Southern Ocean. The animation depicts winds which are blowing at, oh, they've died down since we did show prep here. They were at 64 miles an hour. Now they're only at, there we go. There's some 60-mile-per-hour winds in the Southern Ocean. Looks like a bad place to be going boating. And the wave height there is 36.4 feet. So those are the world's largest waves. That is the worst place to be sailing. Unless you like that kind of stuff, then I guess it's the best place. But that is by far the stormiest portion of the planet's surface heat sinks. Surface heat sinks, otherwise known as oceans. All right, so let's switch to our jet stream maps. There are the jet streams of the eastern world, here blowing backwards over places like the Philippines, India, and the northern Indian Ocean. Here are the surface winds of this side of the planet. Surface winds of the central world, like Africa, Europe, and the Middle East. Here are the jet streams of the central world, and here are the jet streams of the west. Jet stream here still remaining mostly north of the U.S., although there is some strong jet stream action here over the Gulf, blowing in kind of an odd direction, frankly, to the southwest. There is a strong low here, just northwest of the Yucatan Peninsula. Here are the surface winds of this side of the planet, and let's move on to show this Ohio-sized cloud. Check it out. That is one cloudy cloud right there. And by the way, that water is from Lake Huron. I watched it evaporate just yesterday. That is a big cloud, and that is a strong enough system there to be actually creating some cloud cover right over my head here. We're located right around this area here in Lehigh Valley, Pennsylvania. So Ohio, they're getting inundated. The western part seeing some severe thunderstorms. A bunch of Canadian water there from Lake Huron, making its way down almost due south in the past 12 hours or so. Again, these videos are based on what I would be looking at, so this is all subjective information, subjectively chosen information, coupled with a bunch of facts to give me an idea of what's going on planet Earth. All right, so here is our satellite imagery. This is clouds and fog. It's too dark over most of this map to use the visible satellite, so that's what's going on for clouds and fog. No, the galaxy is not controlling Earth's weather. No, the galactic core is not dangerous in any way. No, the galactic core, Sagittarius A star, is not controlling the sun or flipping the poles. And no, CERN is not responsible for solar activity. CERN largely contains its magnetic fields, not transmits them to the sun. Next, our smoke map, thanks to firesmoke.ca. And geez, the Pacific Northwest there, pretty smoky. That is the forecast. I usually show this at 5 FPS. I don't know how I got to 8. I don't know how I got to 3 either. I want it to be at 5. There we go. There's 5 frames per second. And let's move on to our weather.gov map. So that's what's going on. Mostly heat warnings there. If your location is lit, head to weather.gov and click your location. Those are too many locations for us to cover. Weather.gov. And let's break out a forecast here. And there you go. Since the main forecast is for extreme heat, mainly in the central part of the U.S., here's your 72-hour GFS temperature anomaly forecast. It is in degrees Celsius. Again, it is a 72-hour forecast based on the GFS model, and that is where you can expect temperature anomalies to be in the coming 3, as in days. Next, your lightning mapper, and some severe extreme lightning here, especially across western Ohio at the moment, and it's actually moving to the southwest, which is not a normal direction for weather to flow. It's because there's a huge anticyclone over the U.S., and that is controlling weather patterns. Let's take a look at these terrestrial strikes, which are, it looks like they're chilling a little bit here. Cincinnati's getting hit. Mainly southeast of Cincinnati there. So Cincinnati may be seeing some damaging wind and hail, possibly even tornadic activity there, as the most dangerous place in a severe thunderstorm in the northern hemisphere is the northwestern corner of the storm. That's where tornadoes tend to form the most. And I feel like a broken record when I say next time you hear thunder, check out lightningmaps.org. It could save your bacon. And by the way, our channel's saving your bacon from nonsense about space weather. So congratulations on realizing it exists. It's only the most comprehensive daily space weather content and most detailed imagery of the sun you'll find in the known universe. Coming at it from a cosmology perspective, I'm interested in the implications of heliophysics on cosmology, because there are some adjustments that need to be made in some models. I'll just say that. It's not because cosmologists are idiots. It's because our basis for understanding what's going on in distant galaxies is based on what we believe to be going on in the core of the closest star. So any kind of a paradigm shift in that is a paradigm shift in cosmology. It's not like they're gathering a bunch of useless information or that they're idiots. It's just that we have to consolidate knowledge and come up with new models for things. For things. If you enjoy the content, press like and subscribe. Did you know that our thumbnails contain more valid information than entire channels? By the way, we launched a massive web ring in 2019. It was in response to the pathetic, putrid, disgusting, ridiculous, un-American, and evil censorship, indeed criminal censorship, by a certain social media organization who will remain unnamed. It's on the screen. Smashomash.com, and welcome to the Neo Renaissance. Help out the channel by clicking our links. Go visit us on social media, press the share button, leave a comment, whether nice or mean. I guarantee you, we read all comments. Today's featured product is the one I'm wearing. Did you know that Google does not even want you to use the word Google as a verb? Yeah, it's true, folks. Google does not want you to use the word Google as a verb. There's some reason behind it. I don't remember what it is. However, if you are using it as a verb, please make sure you use it correctly, because what it means is to use the Google search engine to obtain biased search results on the World Wide Web. So, just so you realize that, I mean, I stopped using Google as a search engine in around 2012 when I searched for a URL and I had to dig 12 pages deep. Why is that? Because of bias. Why is it biased? Because you're able to raise the search results for your organization by paying off Google, which creates a bidding war, which is not an objective search result. It's based on how much payola is offered to get you higher and higher on the search results list. That is not how Google became the world's leading search engine. The way Google became the leading search engine is by having a simple search algorithm, which causes your results to be in order of most clicked on. That's not what happens anymore, because it's returning biased search results. So if you're going to use it as a verb, and please don't, it makes my ears bleed, Google it. Obtain biased search results for it using the Google search engine. Today's featured product on the Amazon shop, and this one is one of the most fantastic additions to our living room. It's a great $53 spent. The Drive Medical adjustable non-tilt overbed thing. You see them in hospitals, right? That's, people are eating in hospitals or using these things. Put a couple of these in your living room and you'll have a modular adjustable series of small tables in your living room. It's just fantastic. Also, perhaps supplement your home office with that. Amazon.com/shop/SmashOmash, links below the video and on the homepage to that. You can also check out the Hemp Lucid shop. Various different products available there. Help support the channel this way if you like. The body balms are back in stock. That's good news. I'm a big supporter of the mushroom gummies. The stress and the focus mushroom gummies are two of the products that I use on the regs. So help support the channel that way. Increase the probability these videos will continue to exist, remain publicly visible, and free for all to view by supporting the channel via tangible objects. If you want to support the channel via subscription services, the best way to do that is by becoming a member of the Smash Team. The best value is the gold annual paid-up subscription. SmashOmash.com/Smash Team launched in October of 2021. Our custom subscription services site is simply superior to Patreon. It's not because we have anything against Patreon. We are still on Patreon. However, our own site contains additional content, especially for Gold Smash Team members. There's also a silver and a bronze level. The bronze level will cost you $0 per month at SmashOmash.com/Smash Team, and we even send out email alerts for videos just like this one. Let's close out this video with the U.S. Doppler radar map. Check it out. Multiple bands there of quite heavy precipitation indeed. It is a storm the size of the state of Ohio, directly over the state of Ohio. Let's briefly zoom out and show the full 50 states view, as there is precipitation happening in the largest state. We'll focus on the lower 48. There's where things are now. Here is the clouds and fog map, shortwave radiation, part of the NASA GOES Interactive Weather Satellite Suite. And you can see that clockwise rotation over much of the country. That is the anticyclone that we were talking about. It is a massive, giant, high-pressure zone. Kind of like Jupiter's Great Red Spot, only Earth is not a gas giant, so an anticyclone on planet Earth is very different than one on a planet as rowdy as Jupiter. However, it is the same feature. It is a high-pressure zone. Really, it is a depression. It is a pressing down from the atmosphere on the planet, the opposite of a low. A low is essentially like a lifting up, and a high is essentially a pressing down. That's why high-pressure systems blow and low-pressure systems suck. The winds that are generated by a hurricane are actually a suction. Anyway, here's a recap. U.S. Doppler radar. This depicts vertical motion in the air column. Data derived from ground-based systems known as Doppler radars. Here's a space-based system depicting clouds and fog and 3.9 micrometer infrared radiation. It's to view clouds and fog at nighttime when it's too dark for the visible satellite. And water vapor will clear things up. And you can see huge pressure gradients being created there as that moisture is constrained by some dry mass of air. And the reason it's moving in the direction it is because of that anticyclone. Anyway, it's time to close this thing out. Thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. SmashOmash, signing off. And may that solar wind be at your back.